You ever stop to think about the ground you're standing on? It feels so solid, so permanent, right? But what if I told you it's actually a story, an absolutely epic tale of creation, destruction, and transformation, playing out over millions of years? Well, today, we're going to peel back that surface and dive right into that story.
All right, so to get us started, I've got a little puzzle for you. What in the world do a volcano, the Taj Mahal, and a lump of coal all have in common? I mean, think about it. They seem totally unrelated, right? You've got this violent, fiery force of nature, a stunning man-made wonder, and, a chunk of fossil fuel. But believe it or not, they share a deep, hidden connection.
So what's the big secret? It's the rock cycle. That's the link. Each one of those things, the volcano, the monument, the coal, is a perfect example of a key chapter in this incredible planetary story. They introduce us to the three main types of rocks that build our world: igneous, sedimentary, and metamorphic. So where do we even begin a story this big? Well, we start with the volcano, of course. I mean, like any good epic, this one starts with a bang. It starts with fire. And that brings us to our very first type of rock, igneous. And the name itself is a dead giveaway. Igneous literally comes from the Latin word for fire, which is ignis. It's pretty on the nose, right? Because that's exactly where these rocks are born. So the basic recipe is actually pretty simple, but incredibly powerful. All you need is molten stuff from way deep inside the earth. We call that magma. You just let it cool down, and as it cools, it hardens, it solidifies, and bam, you've got brand new rock. That's how every igneous rock gets its start. Okay, but here's where the story kind of splits into two different paths. Path number one, the magma gets trapped inside the Earth's crust and cools down really, really slowly. That gives us what we call intrusive rock. Path number two, the magma erupts out onto the surface as lava and cools super fast, almost in a flash. That's extrusive rock. So, same starting point, but two totally different outcomes. And I guarantee you've seen both of these. Granite, the stuff in kitchen countertops, that's a classic intrusive rock. It took its sweet time forming deep underground. And then there's pumice, that super weird, lightweight rock that's full of holes. That's extrusive. It cooled so quickly that a bunch of gas bubbles got trapped inside, which is why it can even float on water sometimes. All right, so we've covered the explosive, fiery beginning. Now let's shift gears completely. The next part of our story is, well, it's a lot slower, way more patient. We're moving on to rocks that aren't born from fire at all. Instead, they're built, little piece by little piece. Meet sedimentary rocks. Making a sedimentary rock is basically a two-step process. First up is deposition. Just picture it. All these tiny little particles, bits of minerals, tiny plant fragments, all sorts of stuff, settling down at the bottom of an ocean or a lake. Then comes step two, compression. We're talking millions of years here. Layer after layer builds up, and the sheer weight from above just squishes everything together, cementing it all into a solid rock. And aha! This is where another piece of our puzzle from the beginning clicks into place. Sandstone, a classic example of this. And so is coal. That's right. Coal is formed from zillions of layers of ancient plants that got compressed over time. So that lump of coal isn't just some rock. It's literally a piece of ancient history built from the leftovers of the past. Okay, so let's recap. We've got rocks born from fire. That's igneous. We've got rocks built from tiny pieces. That's sedimentary. That brings us to the grand finale, the third act, transformation. This is where things get really interesting, because this is where existing rocks get completely changed, forged by unbelievable heat and pressure. I really love how this is laid out, because it's basically a simple formula. You take any rock that already exists, doesn't matter if it's igneous or sedimentary, and you add two things, incredibly high temperatures and massive amounts of pressure. You mix them all together deep inside the earth, and boom! You get a totally new kind of rock, a metamorphic rock. But, and this is a big but, this is not a quick change operation. We're talking about a transformation that happens so incredibly slowly. It can take thousands upon thousands of years. Now, here's a really important point. The original rock doesn't actually melt. If it melted, it would just cool down and become igneous rock all over again, right? No, instead, the heat and pressure basically bake it. Think of it like putting something in a pressure cooker. It doesn't melt, but it fundamentally changes, becoming denser, more compact, and something entirely new. And the results? They can be absolutely stunning. The slate we use for roofing, that's a metamorphic rock, and so is marble. And that,
That brings us to the final piece of our puzzle, the Taj Mahal. That whole breathtaking building is made of marble, a rock that went through this exact intense transformation. So, there you have it. We've solved our little puzzle. We've followed the journey from volcano to coal to the Taj Mahal. But before we wrap up, I've got a couple more mind-blown facts that really show you just how massive this whole cycle really is.
Okay, get ready for this. After everything we've talked about, all the different types of rocks, if you were to look at the Earth's upper crust as a whole, those original born-from-fire igneous rocks, they make up a whopping 95% of it. 95%! Everything else, all the sedimentary and metamorphic rocks we see, is really just a thin little layer on top. Igneous rocks are, quite literally, the foundation of our world.
And that's what brings our whole story full circle, right back to the Taj Mahal. It's so much more than just a beautiful building. It's basically a monument to the rock cycle itself. It's this incredible testament to the power of geologic change. So in the end, the ground we walk on is anything but static, right? It's more like a massive, dynamic library full of stories that are constantly being written, torn apart, and then rewritten. It just makes you wonder, doesn't it? What kind of new stories are being forged deep in the earth right now? What will this very ground we're standing on look like in another 1,000,000 years?